Hello and welcome to our mathematics lesson. We are going to continue to look at the topic right angle triangles, that is under the whole subject of measurement and geometry. We have been able to look at several aspects on this particular right angle triangles all through from the Pythagoras theorem up to and including the trigonometric ratios and how we can be able to use trigonometric ratios, that is the sine, cosine and tangents, to solve particular problems that involve trigonometry. This time we want to introduce and learn something on bearings. It will be understood that bearings are normally used to indicate direction. And these directions are normally based on the four compass directions that we have, that is the north, south, east, and west. So that particular compass normally points to a location where one is at a particular point of time. And therefore, because it pins out or it indicates the direction and therefore the location of an individual at a given time, then it's normally used majorly by the navigators. These are those people who navigate either the seas or oceans by use of either ships or sometimes the use of boats. Then by the aeroplanes which are flying at a given altitude, they make good use of these bearings for them to be located or to locate their positions at a given or at a particular given period. From the four main directions in a compass, that is the north, east, west, and south, we can be able to come up with 12 more directions that can be able to point to a particular individual at a given period of time. So we need to understand something about the compass, because we shall be relating the angles and the distance one is at a given time. So we have said that this is the north or the North Pole. This is the south side of the compass. This one is the eastern side of the compass, and this is the western side of a compass. Of course, that is the reference point. So from that, we can be able to have two more, in fact, four more directions. So this being between the north and the east, normally bisect this angle made between the north and the east into two, and is normally referred to as the northeast direction. This other bisects the angle made by the east and south into two equal parts, I mean this particular angle, and is normally referred to as the southeast direction. We have this one which is bisecting the angle between south and west into two equal parts and is normally referred to as the southwest direction. Then we have this other one that bisects the angle made between the west and northern direction into two. This one is referred to as the northwest. We'll discover that we tend more to use north and south in naming our other peripheral points or direction. So from this, again, we can have several other directions. We can have that one, We can also have this one. We can also have that one. So again, we read from the north. So this particular point here will be referred to as the northeast, because it is dividing the angle made by the north and the northeast. Therefore, it's called the northeast. This one here, again, the point of reference is from the north, will be the northeast direction, because it is dividing the angle made by the northeast and the eastern into two. Then this angle made by the southeast and the east, so we can have another one here. This one here is referred to as the southeast because of that, then east, so that is the southeast. Then this one between south and southeast is the southeast direction. This one between the south and southwest is southwest direction. This one between southwest and west will be referred to as the southwest direction. Then we now go back again to our north. So this being the northwest, this being the west, the angle at the line or the point here will be the northwest because of this northwest, that will be the northwest. Then this final point here again is between the northwest and north. Therefore, this point here shall be northwest. Back to north, but because we are all measuring from this particular point, so it will be northwest. This one was northwest. So if you count this one in number, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there are 16 possible directions which can be given or pointed out by the compass. 16 different directions. And the 16 are the ones which we are going to be looking at, or we are going to make good use of them. Now, angles are normally measured clockwise from the North Pole. So like in this case, this is the North Pole. Any angle, if you have to measure any angle, you have to measure it clockwise. Clockwise means you are moving in the clock direction. So all angles are measured in that particular form. And then in the case an angle is maybe less than 100, that is less than 3 digits, you must add a 0. So like we cannot talk of angle 36 degrees from the north. You must add a 0 so that you talk of 36. So we are saying that a bearing is an angle that is measured in the clockwise direction. We measure angles in the clockwise direction from the North Pole, and you have said it's normally written using or by making use of three digits. Example, or e.g., I had given you an example of 36 degrees. You cannot just write 36 degrees. You must write 36. If it is 8 degrees, it's not just 8, it is 8 degrees, etc. Again, sometimes a letter T can be used to refer to as the true north. We have what we call the true north, and we normally use a letter T to denote that. Like for example, when you had that compass, this was the northeast, which is bisecting this angle into two, meaning it is 45 degrees. So in this particular case, you can be able to say that the angle is 0.45 degrees northeast. But in reference to the true north, this is 0.45 degrees T. So that's how we sometimes make use of the true north. Bearing of a point to a given point. We can have 2 points, let's say point O and point A. These are 2 points on a plane surface. We can be required to find the bearing of A from O, or the bearing of O from A. So that means that we need to come up with the true north on all these, or on these 2 particular points. So on point O, you try to come up with the true north, so that is our north. Also on this other side, that shall be our true north. So if you want to find the bearing of O from A or A from O, then you join those 2 particular points with a straight line. So this will be O, that will be our A. We have said that all angles are measured from the true north, and therefore the bearing of A from O shall be the all of this particular angle there. The same with this particular A, the bearing of O from point A, we again measure clockwise from O, and that means we begin from the North Pole up to that direction. So this particular angle here will be the bearing of A from O, while this will be the bearing of O from the point A. So this is the bearing of point A from O, while the whole of this angle here will be the bearing of angle O from a point A. And this will always tell you that if, for example, this angle was 45 degrees, that means that because this line and this line are parallel, this will be a transversal, and therefore the alternate angles will be 45 degrees. That means this will be 45 degrees. And therefore, if you want to find this other angle, that means you will take 360 degrees, you subtract the 45 degrees, which will have been already covered, giving you a total of 315 degrees. So you can be able to say that from A, O is 315 on a bearing of 315 degrees, while from O, A is on a bearing of 0.45 what? Degrees. Example, for the diagram shown, give the bearing of 1, A from O, and 2, O from A. Our diagram is that we have point O and A. That is the point O, and that is the point A. We are supposed to obtain or get the bearing of angle A from O and also O from A. So we have said you need to come up with the northern mark. You indicate that that is the northern side. This one is the northern side, and this will be the line joining the two places on the plane figure. We have been given that this particular angle is 120 degrees. It's 120 degrees. From there, we are now supposed to get the bearing of A from O. So that is very clear that from point O, the bearing of A from point O will be the whole of this particular angle, which we have already been given, and that is 120 degrees. So we can be able to say that the bearing of A from point O is 120 degrees. Now, given that the whole of this particular angle is 120 degrees, and that this one alone is 90 degrees, that means we can be able to find or obtain this other angle. And in this case, if this is 30, if this is 90, and the whole of it is 120, we can be able to find this angle. That will be 120 subtract 90, giving us 30 degrees. That tells us that this particular angle is 30 degrees. And if this angle is 30 degrees, that will also indicate that because this line and this line are parallel, this one acts as a transversal, and therefore for alternate angles are equal, this angle will be 30 degrees. That means the angle, that means that the bearing of point O from A shall be, we said we measure clockwise, will be the whole of this particular angle. That means we come from this to 90 to 180 to 270, then we add the 30. Or alternatively, we can take angles at a point which is 360 degrees and we subtract this angle that has not been taken care of. And given that this is 30 and that is 90 degrees, then this other angle will be 60 degrees. And therefore, the angle or the bearing of point O from A will be 360 subtract this one, which will leave us with 300 degrees. Therefore, we can say that the bearing of O from A is 360 subtract 60, which is 300 degrees from a point A. From point A. So you'll have to go around like that, or we have said you go, that is 90, 180 to 70 plus 30, which will give us 300 degrees. Example 2, we shall now be combining the bearings and the trigonometry to find distances and also sometimes those particular angles. So we are told that a bushwalker walks 3 kilometers on a bearing 3 kilometers, on a bearing of 060 degrees from point A, from some given point A to point B. So he walks from point A to point B. Find how far east. Find how far east the bushwalker, how far east, that is to the nearest to 1 decimal place. Find how far east B is from point A. So we want to find how far east. So we have been told that there's a bushwalker who starts walking from some point A. So that is the point A. We said you must have the northern pole. We have been told that he walks at an angle of 60 from, and that is from the north pole. We said that all angles are measured from the north. So 0.60 can be here. So that is 60 degrees. We have been told he walks for a total distance of 3 kilometers to another point B. So that is point B. Again, this shall be our northern side. So we have been asked to calculate or find how far east. And we understand that given that this is the north, this is the west, this is south, and this is east. So we want to find how far east B is from A. So that means we are looking for this particular distance. Let us call it X. So we have this distance X. We have been told that the angle made here is 60 degrees. Therefore, this takes us back to the application of trigonometry in solving problems. Because if this is 60 degrees, we can't be able to find this angle because both of them are complementary angles. That means they add up to 90 degrees. And given that this is 60 degrees, we can be able to find its complement, which is 30 degrees. And this one forms a right angle triangle because we headed south, this one headed east. And therefore, this distance is the one that we are looking for. Given that we already have the hypotenuse and we need the adjacent, then we are going to use a trigonometric ratio that has an adjacent and hypotenuse. And that means that we use cosine, which says that a cosine of angle theta is given by the adjacent all over its hypotenuse. And in this case, the angle in question is 30 degrees is equals to the adjacent, which we are looking for. It is X all over the hypotenuse, which in this case is 3 kilometers. Therefore, that means that our X shall be 3 multiplied by cos 30 degrees. When you find the cos of 30 and multiply it by 3, you'll get that X is 2.5981 kilometers, and that is to the nearest 4 significant figures. The question requires us to write down our answer to the nearest 1 decimal place. And that means that our X shall be 2.6 kilometers because 9 is more than 5, therefore it will going to affect the preceding value or figure. So this is how generally questions on bearings come, or problems in bearings can be solved. That is, you must be able to put in mind that angles in bearing are measured in the clockwise direction, majorly from the north pole. or from the true north. Example 3, we are told that a fishing boat starts from point O and sails 75 kilometers on a bearing of 160 degrees to point B. The question is, first, how far east? How far east of its starting point is the boat? And again, we must write our answers correct to 1 to the nearest kilometer. Then 2, what is the bearing? What is the bearing of O from B? So this is again a question that concerns somebody who is sailing. We have been told that this person starts sailing from a point O, and we are told that this particular point O, that is the North Pole, is sailing 160 degrees. So if you make that approximation, that is 90 degrees. Around 160 degrees could be somewhere there. So the whole of this is 160 degrees. And this particular person sails to another point called point B, which is 75 kilometers away. The question is, how far east of the starting point is the boat? So the boat has reached here and it started from here. So how far east we need to measure or calculate or obtain this particular distance. So let us call it x. So given that that is our x, this we said is 90 degrees and the whole of it is 160. Therefore this alone, this angle alone is going to be 160. We subtract 90. That means it is going to be 70 degrees. The horizontal and the line the boat chose is 70 degrees. So we are supposed to find how far east. Now we have the angle, we have a hypotenuse, and we need to get the adjacent to this particular angle. So that again tells us that we must use cosine for us to get the distance this boat travel, or how far east it is from the origin or from the starting point. That will be the cosine of 70 degrees is equals to the adjacent, which is x, all over hypotenuse, which is 75 kilometers. So that means that x shall be given by 75 kilometers multiplied by the cos of 70, which will result to 25.652 kilometers. We are required to find the distance to the nearest kilometer. So that shall be 26 kilometer, nearest kilometer. So the distance or east of the boat to the origin is 26 kilometers. That is to the nearest kilometer. Part B of the question requires us to obtain or find the angle or the bearing of O from point B. That means we are at point B and we want to go to point O. That means the angle we are talking about is the angle which must be measured from the north going all through to that particular point. Now we had said that given that these two lines are parallel lines, this will act as a transversal, and therefore alternate angles of a transversal are equal. And therefore if this is 70 degrees and the wall of that is 90, this is going to be 20 degrees. And therefore you can be able to get the bearing of O from B by taking the wall of this measurement. Or alternatively, we'll take the angles at a point, we subtract 20 degrees. So that will be 360 less 20 degrees, which will give us 340 degrees. Therefore, you can be able to say that O is on a bearing of 340 degrees from point B. Another example. We are told that a bushwalker walks 4 kilometers on a bearing of 0.55 degrees. 0.55 because you have said that they must all be written to 3 digits. That's why we are putting 0 before the 55 degrees. From a point A, to a point B. Find how far east point B is from A, and this should be correct to 2 decimal places. So we are told that there's a bushwalker who is walking from a point A to point B, and we are told it's on a bearing of 55 degrees from A to B. So given that this will be our point A, we can be able to come up with the 55 degrees. Again, it is from the north pole. So 55 degrees, we approximate it to be somewhere there. So that is 0.55 degrees. We have been told it moves to some particular point B, which is 4 kilometers away. So from this other point, we again come up with the true north. So we are told to find how far east point B is from point A. So how far east, that means we advance to the east. When you bring that one south, this is the distance that we are interested in. And because you have been given this one to be 55 degrees, we can be able to get this one by subtracting 55 from 90 degrees, which will give us 35 degrees. Now that we have this angle, which is 35 degrees, we have the hypotenuse, and we are required to find the adjacent. Then we are going to use a trigonometric ratio that encompasses or that has both the adjacent and the hypotenuse, and that is none other than the cosine. So cosine of an angle that is now cos 35 degrees will be given by the adjacent, which is x, divided by the hypotenuse, which in this case is 4. That means that for you to get x, you need to multiply both sides by 4. So that will give us 4 multiplied by cos 35 degrees. That means that x shall be 3.27661 kilometers. That is to the nearest 5 significant figures. But the question requires us to write our answer correct to 2 decimal place. That means that our x shall be 3.28 kilometers, and this is to 2, or to the nearest nearest 2 decimal places. Sometimes you can be asked to find the bearing of A from B. That means from point B, you try to locate where A is, and that means you will come along all these through angles. So that will be 90 plus 90, that is 180. Then this particular angle, because these are transversal of the 2 parallel lines, this will be 55. So that will be 180 plus 55, which will give you 235 degrees. That is the bearing of A from B. The bearing of B from A is 55 degrees, but you have said you write it in 3 digits, meaning it is 0.55 degrees. In fact, that was our second question. Part B of the question is, what is the bearing of A from B? So we have said you take the whole of that, that will be 180 plus 55, which has given us 235 degrees. So A is 235 degrees from point A, and B is 55 degrees or 0.55 degrees from point A. Another example. We are told that a fishing boat starts from point O and sails 60 kilometers on a bearing of 140 degrees to point B. The question is, how far east of starting point is the boat? Part B of the question, what is the bearing of O from B? So the question is clear and very direct, that this boat is starting from point O. If that is our point O, this is the northern side, and sails at an angle of on a bearing of 140 degrees to another point B, which is 60 kilometers away. We are supposed to find how far, the whole of this angle is 140 degrees. We are supposed to find how far east this boat has gone. So from the starting point up to directly north where this particular object or boat is. It will give us a right angle. So given that the whole of this angle is 140 and this one alone is 90 degrees, then that means that this angle alone will be 50 degrees. So that when you take 50 plus 90, you'll get 140 degrees. We are interested in getting the distance from here up to here, that is how far east. Let us call it x. So in this particular case, if you want to get x, again, we are going to use one of the trigonometric ratio that has adjacent of an angle and the hypotenuse of the angle. That means we are going to use the cosine of the angle 50 degrees to give us the adjacent, which is x, divided by 60. That means that our x shall be 60 multiplied by the cos of 50 degrees. That means that our x shall be 38.5673 kilometers. And because we want it to the nearest kilometer, this shall be 39 kilometers. So from here up to here is 39 kilometers. The next question was, what is the bearing of O from B? So again, you stand at point B and you try to locate O from your true north. So the distance or the angle we are looking for is the whole of this angle here. So that means, and if this is 50, this will be 50 degrees. And if this is 50, that will be 40 degrees, given that the whole of this is 90 degrees. So that means that the whole of this angle, using the angles at a point, will be 360 less 40, which will give us 320 degrees. And therefore, we can be able to say that point O is on a bearing of 320 degrees from point B. That was our point B. The final example which I want us to consider to wind up on the issues on bearing is example number 5, which involves a plane flying. We are told that a helicopter flies on a bearing of 140 degrees for 210 kilometers. Then due east. Then the plane flies due east for 175 kilometers. For 175 kilometers. The question is, how far east to the nearest kilometer? To the nearest kilometer is the helicopter from its starting point. Here the helicopter has gone or has taken two directions. One direction, it was flying on a bearing of 140 degrees and it went for 210 kilometers before flying due east, that is towards the eastern direction. We had said that if that is our compass, that is the north, this is the eastern direction. So it went following the eastern side for another 175 kilometers. We are now supposed to find in total how far east from the starting point has our plane or our helicopter traveled. So from we can take this to be the starting point of our helicopter. Let's call it point A, 140 degrees. Let's take it to be somewhere there. To another point, let's call it point B. So the whole of this is 140 degrees. We have been told that it traveled for 210 kilometers. Given that this is the northern side, this is the eastern side, at this particular place, the plane now chose to go or to use the due east up to, let's say, some other point C, which is 175 kilometers away. Now we need to find how far due east this plane is from the original starting point. So that means from the starting point we are supposed to go due east. That means we must look for the whole of this distance. And if you look, this one forms a kind of a rectangle in which opposite sides are usually parallel and equal. So if this is 175, that will be 175 kilometers because it flew due east for 175 kilometers. So we shall be interested to find this remaining part. And given that this is, the whole of this angle is 140 degrees, we can be able to find this angle. That is, we subtract 140 from, 90 from 140, it gives us 50 degrees. So that means that this particular angle is 50 degrees. And given that we have this angle and we have the hypotenuse side, we can be able to get the adjacent side, then add it to 175 kilometers. So that means that due east, the plane will be, we had said that we are going to use a trigonometric ratio that has hypotenuse and the adjacent. That is the cosine of 50 degrees is equals to the adjacent, which is x, all over the hypotenuse, which is 210. So that will give us x to be 210 multiplied by cos 50, which will give us that 134.985 kilometers. Because we are now working on to the nearest kilometer, our x shall be 135 kilometers. So from here up to here is 135 kilometers. But the plane is not at B, the plane is at C. So the general distance east will be 135 kilometers plus 175 kilometers, which will give us 135 plus 175 will give us 310 kilometers. So you can be able to say that the helicopter is 310 kilometers due east. So now this winds up or brings us to the end of this topic, right angle triangles, where we have been able to solve a variety of problems which involves or ranges from trigonometric issues by making use of the right angles. And we have encompassed everything to up to and include the bearings. So this simply demonstrate how bearings can be used or can be applied or can make good use of the trigonometric ratios. Thank you.